Today we're going to be talking about how to determine empirical formulas. We've already gone over our 4 steps, and in this slide we're going to review them briefly, but then we're going to actually see examples, which will really make us understand what's going on here. So to determine the empirical formula, we start off with the number of grams of each element. If it is a percentage, we'll change that percent sign to grams, assuming we've got 100 grams total sample, and we'll just then do the calculation from there. Our second example will give you show you this so you know how to handle it. Then we change, that little delta sign means change, our grams into moles. We know how to do that. We know our molar mass. Then we divide by the smallest number of moles of all of them, and that'll make more sense when you actually see an example. And then we're going to round to the closest whole number. We know that the subscripts in an empirical formula have to be whole numbers. If it's right in the middle, if there's like a 0.5 on there, then we're going to multiply all of them by 2 so that we can get our whole numbers. And we'll see that in the second example as well. So let's go ahead and do these examples so you can see how to work these. We've got the number of grams, so now we're going to change the number of grams to moles. Here we're dealing with calcium, so we can get our periodic tables and remind us to look up calcium on our periodic tables to get our molar mass. And we've got 40.08 grams of calcium per mole of calcium. Okay. That's going to get us our moles of calcium. Let's go ahead and type that into our calculator. 13.5 divided by 40.08, and we get 0.337 moles of calcium. Let's do the exact same thing for the next set of elements. We've got 10.8 grams of oxygen, and oxygen is 16.00 grams of oxygen per mole of oxygen. And so we do that calculation, 10.8 divided by 16, and we get 0.675 moles of oxygen. And we've got a final one, 0.675 grams of hydrogen. And we're going to do the molar mass of hydrogen, 1.01 grams of hydrogen per mole of hydrogen. And so we end up with moles of hydrogen. Let's go ahead and do that. 0.675 divided by 1.01 equals 0.668 moles of hydrogen. Now we're going to look at our final answers here for all the moles. We're going to choose the smallest one. This is 0.3, 0.6, 0.6. This one's the smallest one. So we're going to take all of these and divide it by the 0.337. We're going to do it up there. We're going to do it here. And we're going to do it here. That one's obviously a 1. Let's go ahead and do this other one, 0.675 divided by 0.337. And we end up with a 2. 0.668 divided by 0.337. We basically end up with 1.98. 1.98 is basically a 2 as a whole number. So these are all whole numbers. If you did write them like that, you would round them to that whole number. Now we can actually do the subscripts. So the calcium has a subscript of 1, and we don't write the ones in there. Our oxygen has a subscript of 2. Our hydrogen has a subscript of 2. So the empirical formula for this compound will be calcium O2 hydrogen 2. So that's a fairly straightforward one. We started with grams. We got whole numbers for our final answers, and we just put those whole numbers as the subscripts. Let's go ahead and do another one. And this one is has a little bit more of the quirks in it that you might find in some of the empirical formula problems. So let's go ahead and work on this one. This one's NutraSweet. We're going to actually determine the chemical formula for NutraSweet. So we've got a sample of this NutraSweet. They run it through the analyzer, and they find out that it's 57.14% carbon. It is 6.16% hydrogen. It is 9.52% nitrogen, and it is 27.18% oxygen. All right, let's go ahead and do this problem. Remember, if there's a expressed in percentages, what we'll do is assume that we've got 100 grams, and so we're going to just change that percentage to grams. So we've got 57.14 grams of carbon. We have 6.16 grams of hydrogen, 9.52 grams of nitrogen, and 27.18 grams of oxygen. Okay. We're going to go ahead and use our molar masses to change these guys. 12.01 grams of carbon to 1 mole of carbon. Remember, this is straight off the periodic table. Go ahead and do that calculation. 57.14 divided by 12.01. 4.7577, so I'm going to round that to an 8, if you're doing this with me on your calculators. And we've got moles of carbon, or 4 significant figures, so I'm going to stick with 4 significant figures just to make sure that we're staying with the rules. Do the same thing here. Hydrogen has 1.01 grams of hydrogen per mole of hydrogen. So we'll go ahead and do that calculation. 6.16 divided by 1.01, and we get 6.099 moles of hydrogen. We're going to do the same thing here for nitrogen. Nitrogen is 14.01 on our periodic table grams of nitrogen per 1 mole of nitrogen. And we'll do that calculation. 9.52 divided by 14.01, and we will get 0.6795 moles of nitrogen. And then finally our oxygen, we have 16.00 grams of oxygen per 1 mole of oxygen equals 27.18 divided by 16 equals 1.6987. So we're going to round up to 99 moles of oxygen. Okay. So we've done that, changing everything to moles. Now we're going to do that divided by step right there. So we're going to look at all of these. This is a 4, this is a 6, this is a 0.6, and this is a 1.6. Well, our smallest one is this 0.6. So then we're going to divide all of them by the 0.6 number. So we're going to go 0.6795, divide that by 0.6795, this one by 0.6795, and divide this one by 0.6795. Alright. So you can see we're doing the exact same thing for every one. So there's a little bit of repetition here, but we want to make sure that we get it correct and repeat it for each one, so we're treating them all the same way. This one comes out with a 7.00, which is basically 7. This one, 6.099 divided by 0.6795 equals 8.976, which again, that one's going to come out to be basically 9. And this one, of course, is a 1. And this guy, 1.699 divided by 0.6795 is 2.500. So this one's 2.5. you can see that this being a 0.5, it's evenly distributed. It could be going up to 3, going down to a 2. Either rounding is going to give us the wrong number. So this is where we have to do this one right here, this rule where we say, okay, they all have to multiply by 2. It's not just this one that multiplies by 3, it's all of them. So this one we've got to multiply by 2, and we get a 14. This one we multiply by 2, we get an 18. This one we multiply by 2, we get a 2. This one we multiply by 2, and we get a 5. Okay. Now let's go ahead and reconstruct this actual formula. We've got carbon with a subscript of a 14. We've got hydrogen with a subscript of an 18. We've got nitrogen with a subscript of a 2. And we've got oxygen with a subscript of a 5. So here is our empirical formula for our NutraSweet. So remember these steps and remember what they mean. Remember, if you're dividing through by the smallest one, you divide through every single one by that smallest number.